Alright folks, Nate here with Nate's Electronics and Modifications. This video is a light following robot. This is a very simple design and it works off of op-amp comparators. And I've made it very simple to look at and on the drawings. So if you want to watch this video and make the exact same one, you can go ahead and make it. So I'm going to go ahead and demonstrate this here, and then I'm going to go ahead and turn the lights on and show you how it works with the circuits inside. But basically, I have the lights off in the room, and when you shine a flashlight in front of it, there is two photoresistors in front of this, and it's going to follow the light. So I'm going to try to videotape this the best I can. Just following it. And it follows it. So let me go ahead and stop this, and we're going to go ahead and look at the schematics here and get a closer look up at it. Okay, so we're back. I turn the lights back on and I turn this off so we can actually look at it in the light. But this is a simple light following robot. What I use for this is two geared motors. You have one back here, one on this side. And then for the wheels in the front, you can get these at Lowe's or Home Depot. Let me see here. These Lowe's, you can get them for like a couple bucks at the hardware stores. I mounted those two on. And this chassis, this frame here, this is just an old security system box, but you can use anything. You can use a block of wood, just screw them into the wood or anything. But this one, what comes in handy is there's a terminal block on here, a terminal board. And I took the two photoresistors and I mounted them right here with these screws. I have one here and one here. And basically how it works is this one is covering this vector over here, and this one is covering this vector over here. So if this one receives light, that motor is going to engage, and it's going to cause it to turn towards the light. So then once this vector hits the light, they're both going to be operating. So it's basically just going to navigate and follow the light. It's very simple. And let's get a good close-up here. I'll show you the schematic here in a second. But this is the circuit design for this. And I made it real simple and spread apart so you can see what's going on here. But basically there's two op-amp comparators. I have one here and one here. So you have one on this side and one on that side. And each motor is controlled by a MOSFET transistor. For those of you, that's a metal oxide semiconductor field effect transistor. And basically what I need to do is I need to boost the signal to these motors so they turn on. And you can see the motor here, two wires coming out. And right here is a potentiometer, which I use to adjust the resistance value to calibrate it. Because when you turn it on and you have lights on in the room, you're going to have to set this just right for the light sensitivity. And if you see right here, I have your ground right here. And then this one comes off, feeds off into that op amp. And same for this one, feeds off that op amp. So let's go ahead and check out the circuit here. Oh, one more thing is I'm using two 9-volt batteries. You can use one, it works fine with one, but I use two to get a little bit more current out of it because my kids like to chase this thing around the house and have it chase them with the flashlights. It's pretty cool. If you have kids, you can have them hide the flashlight. When they shine it at the flashlight, it's going to come towards the flashlight. So let's go ahead and look at the schematic and explain it here, how it works. So here is the simple schematic. I have it drawn up. Now there's other ways of doing this. You don't have to use a 741 op amp. You can use those other IC chips that have two 741s in them. So you can actually just use one of those to replace both of these. But I use two just for education purposes. But if you look right here, this is our resistor 1, our 10K resistor. And this here is adjusting our voltage coming in right here to the non-inverting portion of the op amp. Now the inverting portion right here, we have a voltage divider here. For R2, you got a 470 ohm, and then for R3, you have your right here, your photoresistor. And what happens is when the light hits this, your resistance value is going to change. And when this resistance value changes, a certain voltage is going to be applied to the inverting port of your amplifier. And you set that reference voltage with your potentiometer right here. So when you set it, this is going to trigger a certain voltage. So let's hypothetically, let's just say it has to be 4 volts here for it to engage an output to turn on the motor. Once this hits 4 volts, this is going to be set for 4 volts as well. So when this hits that mark, boom, it's going to cause this to go to saturation, and your signal is going to flow into your gate, and it's going to be boosted from your source coming up from your ground, and then your drain is going to come out, go in your motor, and then it's going to feed in your positive portion of your voltage. Same for your other side, same configuration. And a few simple formulas here. You don't have to get into these if you want to just build the thing. But this is going to determine your voltage reference, what's going to be right here, based on light intensity, and what's going to trigger it. But again, you can see that on my other lectures on op amps, so we're not going to get into the details here with this. The components you'll need for this is you're going to need one 10K ohm variable resistor potentiometer, two 470 ohm resistors, two photoresistors, two 741 op amps, two DC motors, preferably geared. You can use a regular motor, but I prefer the gear ones because it just gives a better operation. Two MOSFET transistors. For your power supply, you don't have to use a 9-volt battery. You can use up to 14 volts DC power supply. However you want to do it, you can get some battery supplies. You can probably go less than 9 volts for this, but I just like to use 9 volts because it's very common battery and easy to hook up. A breadboard, or you can use a solder board, depending. I like to use breadboards because I'm going to modify this and do something else with it. And then, of course, you need a frame and tires. So let's look at this one more time. Let me zoom out of the schematic here so you can see. If you want to pause it and look at how it's wired up. And then I'll come over to this portion right here. Sorry for my art skills, I suck at drawing. And then again, this is the light following robot, so I'll go ahead and show one more demonstration of this thing, and that'll be it. Again, this is Nate's Electronics and Modifications. I hope you enjoy this robot. If you have any questions about it, or any ideas you want to see me doing these videos or create, please post down below, or please subscribe. Thank you.